Hello guys, welcome to Percona Live Online 2021, the biggest conference around the world about open source database. It's great to be here and it's an honor to be talk about MongoDB with you guys. Okay, let's move on. My talk is about how MongoDB surviving after nuclear shutdowns. We discussed about the options that MongoDB implements in farm durability. Okay, this is information about me. My name is Alexandre Araujo. I'm a senior database engineer. I have 15 years of experience with data. Before data, I work as a developer. I started with a relational database in SQL Server 7. It's a long time ago. Okay. Today I work in Brazil in a company called DBAcorp, helping a lot of customers to get to the best results within your database. Okay. Over the years, I have worked with MongoDB, SQL Server, Cassandra, Redis, and Kafka. Okay. And the agenda today, we're going to talk about how MongoDB internally has a powerful mechanism to face unexpected interruptions, combining journalism and checkpoints. And we'll talk about what WAL protocols means, how works the journal process, the kind of disasters impacts the MongoDB, and why we have much concern about points of failure. And when recovery process take actions, we have a step-by-step the process in a recovery method, and some configuration and strategies that you should use in your deploy. Right-hand log is an industry pattern. Okay, it's every database implements, and it doesn't matter if you're commercial or open source database such Oracle, SQL Server, MySQL, and Postgres. Everyone implements right-hand logging. Okay, and also doesn't matter your configurations in MongoDB is PSS, primary, secondary, or PSA, primary, secondary, and arbiter. We are going to focus in the MongoDB demo, okay? The recovery from MongoDB demo. This is a little illustration about evolution. It's called database Darwinism. Okay, it's a trick name. There's some pictures here that's the important facts in the history of the World War II, Cold War, and clothing data explosion. I think clothing data explosion is so important that Cold War and the War II. Just a little funny here. Okay. But after World War, the databases were made in flat files using magnet tape and magnet disk. And then in the 70 years with code, code implements relation database. And there's until today, relation database rocks, okay? With Oracle, SQL Server, MySQL, PostgreSQL, and open sources in the last, you can see in the next, I think the next, yes, you can see in the next slide how open source is today in the center. And the cloud and data explosion is take a lot of deployments, kind of tools and databases. MongoDB is in the last 10 years has an important in the center with a lot of vendor clouds such as Amazon, GCP, Kafka, Kubernetes, a lot of things. And there's a lot of trends in the future. Yeah, the market is still change. Okay, in the future we will have the database time streams, database time series, blockchain database. MongoDB is planning to use the new blockchain database. Okay, you can see the next MongoDB word, the release, who knows, the next blockchain database inside MongoDB. And a lot of cool stuff. It's, I think it's a golden era for data professionals and data at all. Okay. Here's a graph from dbengines.com. dbengines.com is a wonderful website with a lot of rankings. For example, ranks about database documents, database relation, database graphs, and there's a lot of rankings. And here's the point: open source today takes the lead, overtakes the commercial license. Open source today is most used by commercial license. If you return here 7 years, open source is almost 40% of the license, and commercial almost 70%. And today, open source takes the lead. It's a great moment in the history of database that will be celebrate. And I think it's so wonderful. Okay. Who knows how the market will be in the next 7 years in 2028? Okay, I can bet my money that the open source is still in the leads, maybe with a large margin from the commercial license. Okay, how? Let's talk about MongoDB storage engine. Storage engine is common in any kind of database system, managing how data is stored. Okay, MongoDB provides a variety of storage engines. Since the older versions with MMAPV1, now the last years WiredTiger and MongoDB InMemory. According to your deploy, you can choose the best solution for your storage. But the almost application uses WiredTiger. WiredTiger is the default storage engine since MongoDB 3.2. Okay. All right. Okay. There's information here. In MongoDB, in the last version 4.2, MMAPV1 is deprecated, is not more used. If you update your MongoDB old versions that use an MMAPV1 to MongoDB 4.2, you have to change to WiredTiger. Okay. WiredTiger uses snap compressions by default with 100% of compression. Okay, snap compression is a library written by Google. It's a wonderful library. Also, MongoDB in the later versions releases the Z standard compression. Z standard is written by Facebook team. Is another great compression. And the older zlib is still in existing Mongo. WiredTiger implements the storage engine is using C API, although WiredTiger has WiredTiger in Python and Java, but MongoDB chooses the C API. Okay, WiredTiger has a lot of advantages of modern hardware with a lot of new CPUs, memory, and the work in the threads. It's a very nice. Okay, and eliminating blocking due to concurrence. Control using multi-version concurrence control. MVCC is wonderful because your locks and lets and IOTs, it's in the other word with MVCC. Okay. Also, a traditional database SQL Server, and there is a feature called the in-memory SQL Server that uses MVCC. Okay, but it's not. It's just a little feature. Okay, it's not comparable to MongoDB that the whole storage is using MVCC. Okay, WiredTiger is 10 times better with about throughput from zlib or the older storage. Okay, Sorry about not lib is compression. The WiredTiger is 10 times better and that's 10 times faster than MEPV1. Sorry about that. Sorry about the confusion. Okay, the documentation here is about WiredTigers, the link here. Okay. This is the architecture of WiredTiger using C API. There's a sub-proxy here called transactions. Transactions is do not mix up with the transactions, the user transactions released at the new versions in MongoDB since 4.0 that implements transactions. It's not the same transactions. Here the transactions subsystem in C API, the name is the same, but his is about durability, okay? When you write some data, we use transactions inside the WiredTiger, but just for keep the journal and checkpoints. So both checkpoints and journal using the transactions subsystem API. Okay, let's see. There's internal stuff about the WiredTiger. Okay, WiredTiger storage engine has 3 durability modes. In memory, write no sync and full sync. Okay. In memory you can lose data, obvious. In memory, you can, regardless among the crash or operation system crash, you can lose data. Write no seeking, there's a trade-off here. Data is recoverable with MongoDB crash, but you lose data with system crash. Full sync is 100% recoverable. Okay, MongoDB uses 2 modes for durability: journal and checkpoints, and implements the full sync in WiredTiger. Okay, it's 100% of the data could be recoverable. WAL Protocol, write-ahead protocol, most known as the recovery method, is a pattern for industry. Ensures there a record of every change in your database, which will be available for your application only will be stored in the non-volatile memory, okay, at the disks. If your data is not written in the disk, is not guaranteed and is not returned for application. So WriteAhead protocol implements it's a protocol that MongoDB implements that protocol to guarantee in form of journal and checkpoints. When the data is changed and committed, it's forced to stable data storage. Okay. For example, when send a write in form of update or insert, the data comes to volatile memory. There lives in the volatile memory known as dirt pages. Okay, and dirt pages will flush to disk, and your application gets the commit, but the dirt pages still live in memory until the other proxy that we will talk in the next slide. This next slides. Okay. Traditional databases are right for recover, SQL Server, MongoDB, and MySQL, PostgreSQL. Every database traditional is a right log. Okay. Here's a little data journal from user writes until commit. The data comes to in your application. You are sending interesting write from analytics, app, desktops, mobile systems, IoT systems, sensor systems, any kind of RAID data comes from apps, send the applications to MongoDB. MongoDB receives the data through the query language in native drivers. The native drivers take the data and send it to the MongoDB data model and the MongoDB proxies. And then MongoDB proxies take the data and send it to WiredTiger. WiredTiger call a subsystem inside the transactions and send it from your operation system and written in the storage, inform the journal files, also checkpoint files, okay? And that's the how is the MongoDB implements write-ahead logging, okay? And then when the data is written at the disk, ERPP returns receives the commit, okay? Here's how write-ahead logging works in MongoDB. We have in this area here two areas, volatile memory and non-volatile memory. Your app send updates inserts, WiredTiger write in the at the buffer cache, and then flush the disk to journal files. Journal files, once it's successful, returns the commit for application in non-volatile memory, and checkpoints written your data to collection and index files. Okay, this is how until your data is safe in the non-volatile memory, your application not receive the commit, because if your data lives in memory, you are not stable. There is another MongoDB storage called MongoDB InMemory. That's a different compartment. So don't worry about that. But for traditional operations, write-ahead logging is in that way, okay? And journalism. Journalism is an internal process in WriteTigers. The WriteTigers will create one journal for each write. Every write index operation will create a record inside the journal. The max, the size of your journal is 100 megabytes, and the minimum is 108 bytes. When your journal reaches this 100 megabytes, the new journal is created, okay? There is not a replication log, okay? A replication log is other feature that sync your replicas and your nodes. It's other history. Also, it's not a user-level transactions. User-level transactions is, as I said before, transactions inside MongoDB 4.0 that guarantee transactions is it's in the user level, okay? It's in the user layer. Here we talk about in the WriteTiger layer, in the MongoDB internal layer, okay? And all journal files that we will use in the checkpoints will remove for our journal files, because when we recover from the last checkpoint, we'll check the last checkpoints and applies all the data after the last checkpoint. So in this way, WriteTiger will remove the old journal files to combining the journalism and checkpoint. You'll see in the details in the few slides. Okay. The structure of journalism. Journalism resides at the bpath /journal / WriteTiger log dot a sequence of zeros starting 1 and goes on, okay? And a record per client initiate a write operation, WriteTiger create a single journal for this operation, and each record has a unique identifier. Regardless, you have a write operation you have 10, for example, 12 index associated with your collection, your record inside the journal, it will be unique with the modification in the collection and the 12 modification in the unit, in the index, okay? That's information. Checkpoints is internal. Of course, it's different from journal. Journals occurs when your application sends the right data. Checkpoints is internal, occurs every 6 seconds and create stable data. What checkpoint means? Checkpoints take your dirt data in the memory and written in your checkpoint in your collection and index files. Okay, in this all your dirt dirt data will flush for a collection and index files, okay? And also checkpoint will mark inside the journal indicating where is the ID of checkpoint. This is important because combining checkpoints and journal is will result in a faster recoveries because when checkpoints occur and mark your journal with ID, and when recovers takes action, recovers will check the last checkpoint and applies only the records after the last checkpoint. Okay, it's a very very intelligent. Here's how journalism occurs at every 100 milliseconds. Transaction sends to WiredTiger. WiredTiger in API makes a checkpoint um, written to the log proxies. Log proxies call storage function right in the memory and the journal. Okay. Checkpoints, it's internal, occurs each 6 milliseconds, sent to WiredTiger API, find the data, dirt data in memory, checks the data, find and send the dirt data, flushing to data disks through the snapshot transactions inside the WiredTiger. And then MongoDB will write in the collection in the index files. Okay. Failure centers. What happens after a crash? In case of recovering proxies, the data after the last checkpoint will be applied from journal files. Okay. MongoDB will check the last checkpoints. And after the last checkpoint, all the data after them will be applied in your MongoDB. In your instance will be in recovery until the MongoDB finish to apply all the log after the last checkpoint. Your instance will be in the recovery, and at the end, your instance will be online. Okay. Kinds of failure: writer failure, power failure, storage volume failure, kill unexpected MongoDB proxies, and unexpected restart of system operations. Recovering: how MongoDB recovers from a cache. From a cache. There's a faster recovery combining checkpoints in journal. First check the data with the last checkpoint, as I told you, then apply all the data according to the last checkpoint. MongoDBs do not guarantee storage failure after checkpoint. If there are failure or a bug in your file system, or your hard disk or your storage is corrupted, or maybe something destroy your storage, okay, after the last checkpoint. And at the moment of the crash, the MongoDB after the last checkpoint, you cannot prevent, MongoDB cannot prevent it because you lost your storage, okay? So you have to use replication or redundant array, such in form of RAID, redundant disk to defend you against storage failures, okay? But it's only data after the last checkpoint, okay? If you are, for example, you have a crash after a last checkpoint, all the data between the last checkpoints, if you lost only the storage, okay? If you have a power failure, MongoDB, is it any kind of failure, you guarantee you'll be safe because your data is after the checkpoint lives in the disk. So you apply the data. But if you are a storage failure, you have to use a replication or some kind of redundancy of your disk, okay? Recovery proxies. How recovery proxies take actions. Here's your application send the operation, send the data called Seahawks. Seahawks write operation first in WiredTiger memory from transactions API inside the WiredTiger, and then after the MongoDB journal, written the disk in form of journal. At this moment, your Seahawks lives at dirt page, okay, and then goes on. Another data comes, Panthers, same thing, Panther journal, written post Panthers in your disk, Packers, and here's a checkpoint. At this moment, your three data, Seahawks, Panthers, and Packers, are dirt pages, dirt data, okay? When checkpoints occur, all the data will flush to collection files. At this moment, your data in the memory will become clean data, okay? It's a trick from WiredTiger. Just change the dirty data to clean data, okay? Releasing new space from another dirt page, okay? And then dirt page came, stealers, journals occurs, another checkpoint send the data to your collection files, your stealer data becomes clean data, then eagles, journal occurs, and then a crash. In a crash, we will, after the crash, we will restart your MongoDB process, and MongoDB process you begin in a recover process. The recover process will check the last checkpoint and applies only data of your last checkpoint. As you can see, your collection files has the data until stealers, but your collection doesn't have the data called eagles. So eagles will live as a dirt page, but also because of the journal, eagles live in the journal files. So the recovering process find the last checkpoint here after stealers and applies the eagles data, and we will write recovery proxy will write eagles in your collection files and change the database online. Okay, so it's a nice. Agora, imagine a billions of transactions in your log. Could be impossible. Applies all log in case of crash because your log will be very large. Okay, so combining checkpoints in journal, when checkpoints occurs, marks the journal with the last checkpoint, will make faster recovery because you have to only apply recovery after last checkpoint. And the checkpoints occurs at every 100 milliseconds. Okay, so it's very nice. So eagles here is in collection files. This some points when you use MongoDB InMemory. Okay, performance is a good indicator for using MongoDB InMemory. Only becomes durable when filling the memory. When you are deploying, reach your buffer cache, so the data will become durable because you have to flush the memory to allocate the new data comes to buffer cache. Okay, your data will become durable when a new journal is created, and even if you use MongoDB memory, and if your system has a point of times that is a idle system, so MongoDB can trigger the right journal every 50 milliseconds if your system is idle, okay? And of course, some kind of crash will not guarantee the data after the last checkpoint because you don't have the journal active in MongoDB deploying memory, okay? Here's some tuning that you can use in your architecture, in your clusters, and your shards, combining durability with your deploys. There is a option in configuration file called committed interval milliseconds, where you can set your value for the commit, set your value for trigger your journal. Okay, the journal is 100 milliseconds default. but the range can be between 1 and 500. For example, if you use a lower value in commit interval for your journal, your storage will be very intense. But if you use a higher value, your storage is not so be intense. Okay, you can use Symlink for journal to increase the concurrence with your database in your deploys and separating your journal for your database. Okay, this is a point here. Big checkpoints. Imagine your deploy is very intense. You have big checkpoints. Big checkpoints can cause problems of performance, but you can control and make a tuning inside your WiredTiger, limiting the caching size of your dirt pages, controlling your memory because your big checkpoints in your dirt pages, your big checkpoint is very large, your memory is not so very large, so you have a lot of dirt pages. So, but you can control inside the WiredTiger cache size, limiting the size of the dirt pages, inside the threads, eviction threads. But it's a tuning inside the WiredTiger, but you can face some problems with of intense workloads when with big checkpoints. The trade-offs here, of course, if you have a lot of checkpoints, for example, if you put a lower value in your commit interval, we will have a lot of checkpoints, means less records that you reply in the case of crash. Although your storage is good because it's good, no, it's more intense. Sorry, your storage is more intense because you have a lot of intense use of your storage because your checkpoints is very very short. Although you can use a higher commit interval MS and less frequent checkpoints means more record. In case of crash, your recovery will be larger because your checkpoints is, there's a space in between checkpoints. So you have more data, okay, to reply. But your storage will be you have more performance for your database. So it's a good number of performance. Use a commit interval set to 400 milliseconds and use the all power of your storage for database. Because today we can trust in cloud environments, redundancy of a lot of hardwares, but depends of your cloud, okay? But it's there's a lot of deploys you can increase the value of your commit interval, okay? That's it. Open source is the new oil, okay? I think the next 10 years open source will be the new oil, okay? That's it, okay? Thanks about the session. Enjoy the conference. We have to be safe because the pandemic is still between us, but I think next year we can come together in the next Percona events. All right, you can find me at Twitter or by email. That's it. Thank you guys. Bye bye. Cheers and be safe. Have a great event. Bye bye.